What's up, you freaking geniuses? So in this video, I'm going to teach you how to use Pascal's triangle to expand binomials. Okay, so first I'm going to explain what Pascal's triangle is, then I'm going to teach you how to derive each of these equations, and then we're going to do an example at the end. Okay, so Pascal's triangle is just a convenient way of finding just the coefficients of a binomial expansion. Okay, so for example here, it's called the zero row, okay, because we have a binomial raised to the 0 power. Now, anything raised to the 0 power is just equal to 1, right? So that's why at the top of Pascal's triangle, we just have a 1. But Pascal's triangle actually has a pattern to it, right? Because if you see the rest of the rows, it always starts with a 1, ends with 1, right? Starts with a 1, ends with 1, starts with a 1, ends with 1, starts with a 1, right, etc. Now, whenever you expand a binomial, you end up getting the exact same pattern. Right? You start with a 1, end with a 1. You start with a 1, end with a 1, right? Start with a 1, end with a 1, and etc., right? Ones on the outsides, always. Okay? But if you want to find the coefficients here in the middle, right? This 2, the 3s, 4, 6, 4, right? The way that you do that is just you add up the two numbers that are directly above it. So for example, here I said you start with a 1, end with a 1, right? And if this number wasn't here, how would you find it? Well, you would just add up these two numbers above it. 1 plus 1 is equal to 2. Okay? Here, again, start with a 1, end with a 1. If you wanted to find what two numbers go here, you just add up the two numbers above it. 1 plus 2 is equal to 3. And then here, 2 plus 1 is equal to 3. Right? To find these numbers, right, 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. Right? Here, for this last row, same thing. 1 plus 4 is equal to 5, 4 plus 6 is equal to 10, 6 plus 4 is equal to 10, and 4 plus 1 is equal to 5, right? So that's how you find the coefficients. So here you can see just this table anyways goes all the way to the 5th power, but if we had something, for example, like a plus b to the 6th power, and we wanted to find the coefficients for something raised, a binomial raised to the 6th power, well, again, we would have 1s on the outside, just like that. And then 1 plus 5 is equal to 6. 5 plus 10 is equal to 15. 10 plus 10 is equal to 20. 10 plus 5 is equal to 15. And 5 plus 1 is equal to 6. Okay, so these would be the coefficients we would use for a binomial expansion being raised to the 6th power. Okay, so that's the pattern just for the coefficients. Now let's talk about the pattern that happens with all of our variables and exponents. Okay, so the pattern with the exponents. So for example, if we have a random binomial being raised to the 1st power, so a 1, so here on our expansion, all of our exponents should have a power of 1, or they should add up to a power of 1. So here a is the same thing as a to the 1st power, here b is the same thing as b to the 1st power, right? So these add up to just 1. Here, if we have a binomial being raised to the 2nd power, all our exponents should add up to 2. So here we have a 2, and then here, again, we have basically a to the 1st and b to the 1st, so that's equal to 2, and then here we still have a 2, right? So they all add up to 2. Same thing, if something's being raised to the 3rd power, they should all add up to 3, right? So here we already have a 3, here we have basically 2 plus 1, here we have 1 plus 2, and then here we just have a 3. Right, same thing with 4, right? We already have a 4. Here we have 3 plus 1. Here we have 2 plus 2. Here we have 1 plus 3. And here we already have 4. Okay, same thing for 5. Same thing for 6, 7, 10, 100, right, etc. Okay, and the other thing that I want you to notice with the exponents is that they go in descending order. Okay, so for example, a binomial being raised to the 2nd power, you can see that the a's go from 2, 1, and then 0, right? It disappears, right? For the 3rd power, right here, the a's go 3, 2, 1, 0, it disappears, right? The 4th power, it goes 4, 3, 2, 1, disappears, 0, right? And same thing for the 5th power, right? It goes 5, 4, 3, 2, 1, 0. And the same thing happens for our b term, okay? Just going the other way. So it goes 2, 1, 0, disappears, right? For an exponent with 3, it goes 3, 2, 1, 0, disappears, right? With 4, it goes 4, 3, 2, 1, 0 disappears, right? And same thing for 5. It goes 5, 4, 3, 2, 1, 0, right? So if we wanted to find, for example, the next row, a plus b raised to the 6th power, how could we do that? Well, again, we would have to start with our coefficients over here. So again, I'll just write them in really quick. At the ends, we always have 1, and then here we would have 6, 15, 20, 15, and 6. Okay, so those would be our coefficients right here. Now, if we wanted to expand our binomial over here, well, this would be equal to, first of all, we'd have to list out our coefficients over here. So again, 1, 6, 15, 20, 15, 6, and I'm going to make a little room right here, and 1. Okay, now I'd have to write in my a and b terms. Well, remember, this is being raised to the 6th power, so we're going to start with a to the 6th, and then we're going to go a to the 5th, a to the 4th, a to the 3rd, a to the 2, a to the 1, and then 0, nothing there, right? And now same thing for my b terms, right? Starting with 6 on this side. So we're going to go b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st, and then nothing there, right? Disappears. And then the last thing would just be adding our plus signs, right? Because we're just adding all these bad boys up together in here. Okay, so that's how you would derive your own binomial expansion if you had something that's not listed on this table anyways, that I'm going to go over. Okay, so now let's go over an example. So let's say we wanted to use Pascal's triangle to expand the binomial x plus 3 squared. All right, so we have an exponent of 2, right? So remember, the very top means we have an exponent of 0, which is just a 1. Then the next row, we just have 2 1s. That means we have an exponent of 1. And then the next row, 1, 1, and then a 2 in the middle, right? 1 plus 1 is equal to 2. That means we have an exponent of 2, right, for this row. So these are the coefficients we're going to use, 1, 2, and 1. And I'll write them over here. So 1, 2, and 1. So our exponent is a 2 here, so we're going to have a to the 2, a to the 1, and then 0 over here, right? And then I'm going to do the same thing going the other way. So I'm going to have b to the 2, b to the 1, and then 0, right? And then we're just going to add these up, okay? Now we just need to match the variables with our terms over here. So remember, this is a and this is b. So our a term is x and our b term is 3. So 1 times x squared plus 2 times x times 3 plus 1 times b squared, so 3 squared, right? So times 3 squared, okay? Here, 1x squared is the same thing as just x squared. Here, 2 times 3 is equal to 6, so here we have 6x, right? So plus 6x. And then here, 3 squared is equal to 9, and 9 times 1 is 9, right? So plus 9, right? So here we get x squared plus 6x plus 9. All right, let's try one more. So here we have 2y minus 5 in parentheses raised to the 3rd power, okay? So again, the first thing we want to do is just find our coefficients using Pascal's triangle, right? So remember, when you have an exponent of 0, that just means there's a 1 at the top. When we have an exponent of 1, that means we have 2 1s like that. For a 2, we'll have 2 1s on the outside, and then in the middle we'll have a 2. And then for a 3, again, we'll have 1s on the outside, and then here we'll have a 3, and here we'll have a 3, right? So for a binomial raised to the 3rd power, these are our coefficients, right? 1, 3, 3, and 1. So let's write those out. So we have 1, 3, 3, and 1, all right? So now we have to figure out what our variables and exponents are. So here we have a 3, right? So we're going to start with a to the 3rd, right? So we're going to have a to the 3rd, then a to the 2, a to the 1, and then 0, right? And then for b, same thing going the other way. So we're going to have b to the 3rd, b to the 2, b to the 1, and then 0. And then we're just going to add these guys up like that. Okay, so here 2y is our a term, and negative 5, right, make sure you include the sign, is our b term. So let's plug those in for a and b over here. So first we're going to have 1 times a cubed. So a, again, is 2y. So here we're going to have 2y cubed. And then we're going to add that to this next one, which is 3 times, let's see, a squared. So again, a is 2y. So we're going to have 2y squared. B is negative 5, right? So negative 5. And then plus this next one, which is 3 times a, which a is 2y, and b squared. So we're going to have negative 5 squared, right? Negative 5 squared. And then plus this last one, right? So plus 1 times b cubed. And b cubed would be negative 5 cubed, right? So negative 5 cubed. Okay, so simplifying this one first, here we have 2y raised to the third power. So this exponent, you apply it to both of the terms in here. You apply it to the 2 and to the y. So we're going to basically have 2 cubed times y cubed, right? 2 cubed, that's equal to 8. So we're going to have 8y cubed, right? So we're going to have 8y cubed. And 8y cubed times 1 is just 8y cubed. So that stays like that. Okay, next, here we have a 2 being applied again to the 2 and to the y. So it's going to be applied to the 2 and to the y. So here we get 4. So we get 4y squared in here, right? So we're going to get plus, right, plus 3 times that, which again is 4y squared times negative 5, right, times negative 5. And then that's going to be plus this next one, which is 3 times 2y, right, 2y, and negative 5 squared is just 25. So plus 25, or times 25, plus this last one over here. So negative 5 cubed is negative 125, and negative 125 times 1 is just negative 125, right? So here we're going to have minus 125 at the end. Okay, so then here, again, this is still just 8y cubed, so let's write it as 8y cubed. And then here, we just need to multiply the coefficients together, right? So 3 times 4 is equal to 12, and 12 times negative 5 is negative 60. So here we're going to have minus 60y squared, right? Here, 3 times 2 is 6, and 6 times 25 is 150, right? So we're going to have positive, so plus 150y is our variable there, and then minus 125 at the end. Okay, so there's no more terms that we can combine. This is as simplified as we can get it. So there's your answer right there.
So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.